the Pacific Islands Regional Climate Assessment. It's the first of two forums around climate change that will occupy this 8 to 10 time block this morning. And my name is Deanna Spooner. I'm moderating this session. I'm the coordinator for the Pacific Islands Climate Change Cooperative. And I'm going to introduce the panelists actually in the order in which they're speaking, not in the order in which they are sitting. So they will have to raise their hands. First is Dr. Melissa Finucane. Melissa is a senior fellow at the East-West Center in Honolulu and the lead investigator for the Pacific RISA program. She received her PhD in psychology from the University of Western Australia. Her empirical research focuses on the interplay of emotion and cognition and the role of sociocultural factors in judgment and decision processes under conditions of uncertainty. Melissa has published numerous book chapters and peer-reviewed journal articles and is a member of the Society for Judgment and Decision Making. Our next speaker will be Dr. Victoria Keener, who is also a research fellow at the East-West Center and is the program manager for the Pacific RISA. Dr. Keener received her PhD in agricultural and biological engineering from the University of Florida, specializing in hydroclimatological research dealing with the effects of climate variability and ENSO on both physical modeling and statistical hydrology of freshwater pollutant loads. Phew, that's quite a meaty PhD topic, Vicki. She has also done research and assessment on the integration of climate information into public water utilities decision making. The next presenter will be Dr. John Mara, down at the end. John is the NOAA Climate Services Director for the Pacific region, based here in Honolulu. He's also the chair of the Pacific Climate Information Systems, or PACSIS, and an adjunct fellow at the East-West Center. For nearly 20 years, John has been working to bridge science, policy, and information technology to address issues related to natural hazard risk reduction and climate adaptation planning. His area of expertise is the development and dissemination of data and products associated with coastal inundation and erosion. John received his PhD in geology from the University of Canterbury in Christchurch, New Zealand. And our next speaker is Dr. Jeff Burgett. Jeff is the science manager for the Pacific Islands Climate Change Cooperative, or PICSI. Jeff has worked in island ecosystems for most of his professional and educational career and has worked for the U.S. Fish and Wildlife Service since 1995 as a biologist tasked with invasive species, avian diseases, wetland and riparian restoration, coral reef restoration, endangered species recovery, and climate change assessment and education. Jeff has a BA from the University of Hawaii and a master's in science from the University of Auckland in New Zealand. And back at University of Hawaii, he received a PhD. All of these are in zoology with an emphasis in marine ecology. Then I will be rounding out the talks, concluding the formal presentation. And then after the formal presentation, we will be having an interactive Q&A. So at that point, I'm probably going to be calling on everybody to come up. But without further ado, we are going to start with Melissa's introductory presentation.
Well, good morning, aloha everyone. I can't see, but I assume it's up. Okay. So it's my pleasure to start off this session this morning telling you a little bit about what is the Pacific Islands Regional Climate Assessment, or PIRCA as we call it, a little bit about the process, and then turn it over to our experts here to give you a little bit more detail about key findings. The PIRCA is a highly collaborative effort that has, it started about 12 months ago, and it had two main aims. The first was to assess the state of climate knowledge, impacts, and adaptive capacity in the state of Hawaii and the US affiliated islands. And secondly, to support decision-making through the identification of this knowledge in the face of a changing climate. We had many different participants, including folks from government and non-government organizations, businesses, and community groups. And over the last 12 months, we've done many different things. We've had dialogues, workshops, conducted literature reviews, analyzed scientific consensus, identified knowledge gaps, and really tried to highlight the implications for different sectors and our adaptive capacity. And the products so far include a technical report, which was submitted to DC, to the US Global Change Research Program. They're the folks that are running the National Climate Assessment. The next report will be due out next year, 2013. And then a subset of us have been working on synthesizing that technical report to a small chapter that will be included in the National Climate Assessment report next year. And soon we hope to have our technical report published in a glossy format that we can distribute also electronically. And from that we'll derive a number of other products like fact sheets, policy briefings, and so on. Coming up in the winter, we'll also have a forum or a conference here and hopefully in other places in our region to try and have a dialogue, disseminate the results, and also have a dialogue with key policymakers and resource managers. So we'll share more information with you about that as it gets planned. As I said, this is a highly collaborative enterprise. The three main groups leading the effort and trying to coordinate activities included the NOAA-funded Pacific RISA program, which has its core office at the East-West Center and many collaborators at the University of Hawaii and elsewhere, the Pacific Climate Information System, and also the DOI-funded Pacific Islands Climate Change Cooperative. But as you can see from those logos, there were many people and organizations involved, and many of them provided in-kind services and support. And we're grateful to everyone that has been involved so far. So what is this National Climate Assessment? Well, this is conducted under the auspices of the US Global Change Research Act of 1990, which requires a report to Congress and the President every 4 years. And the main aim of this is to try and incorporate science into the larger context to identify vulnerabilities, but it also tries to evaluate the effectiveness of mitigation and adaptation efforts, to try and identify economic opportunities, integrate scientific information from multiple sources, and highlight, of course, gaps in our knowledge. Ultimately, it's really designed to help the federal government prioritize science investments. The first assessment was conducted in 2000, and at that time there was a 4-page chapter on islands that included Pacific Islands and the Caribbean Islands also. And it tried to assess trends, look at projections and potential impacts for these areas. The next assessment was conducted in 2009, so if you do the math, you realize already this is not happening every 4 years as required by the Act. There were very few resources available for the second assessment, and so essentially it was just an update, a revision of the material that was included in the 4 pages of the first assessment. So this time around, this is the third assessment. We've had many more resources than have been available in the past, but I'll still hasten to add that I think the resources were way too limited for the scope and nature of the problem and the timeline that we're working under. So there are some limits and constraints to which are reflected in the final products, but it was enough to allow us to do a much more comprehensive assessment and involve many more people and organizations than has been done in the past. The other change was that we were able to focus only on US-affiliated Pacific Islands and the state of Hawaii, and the Caribbean Islands were included in another region. So the geographical scope is shown here. We divided our vast region into 3 sub-regions. So in blue there we have the Hawaiian Islands, so the Central North Pacific. Green is the Central South Pacific, which is essentially American Samoa. And the Western North Pacific is shown in light orange there. And of course, this is a vast area. Land is scarce. There are hundreds of miles, of course, between islands and thousands of miles between island chains. But this area has many unique human and natural communities of much significance to the global community. And of course, we have many endangered species, over 400 listed on the endangered species list. In terms of the structure of our report and the structure of our approach to this process over the last 12 months, we identified 3 main working groups that had specific focus. So there you see in the center in blue, we have the Freshwater Sustainability and Drought group. Then there was a working group on coastal inundation and sea level rise, and aquatic and terrestrial ecosystems. We also had 2 additional groups looking at climate impacts across a number of different sectors related to the variables that each of the main working groups were looking at. And then we also had a group looking at adaptive capacity at both the institutional and community level. So the structure of the report reflects the three main groups there in the middle, but we also sprinkle through the knowledge that we gained about impacts and adaptive capacity in each chapter. So if you don't have time to read the whole report, I think it's currently around 160 or 180 pages, there is one figure in there that I think captures the main indicators of a changing climate in the Pacific Islands region. And so the highlights here are, of course, that across the region, surface air temperatures are rising, with the greatest increases seen at higher elevations in the Hawaiian Islands. Regional average sea level is rising, with greatest increases seen in the Western Pacific. Rainfall is decreasing across the region, with some exceptions. A slight increase is seen in rainfall in some of the westernmost Micronesian islands, and there's no detectable trend in the South Pacific, in the central South Pacific. Groundwater component of streamflow is decreasing over the last 100 years in Hawaii. There have been changes in extreme climate events, so that would include drought, heavy rainfall events, and tropical cyclones and hurricanes. And of course, ecosystems are changing in many ways in response to these climatic changes. A summary of the core impacts or implications of those climatic changes I'll just present here, and then my colleagues will talk in more depth about both exactly what those changes entail and their potential implications. Of course, drier and warmer conditions mean that freshwater supplies will be more limited, especially on low-lying islands and atolls because of their small size and limited resources. Increasing sea level incrementally over time, of course, means there's a higher likelihood of coastal flooding and erosion, which will damage agriculture and infrastructure and negatively impact tourism, and also reduce habitat, for instance, for endangered species such as monk seals. Changing ocean temperatures and acidification means changes in marine ecosystems. We expect to see increasing events of coral bleaching, disease, and death, and of course, shifting distribution of coastal and pelagic fisheries. The warmer and drier conditions are also expected to continue stressing native plant and animal populations. In particular, we expect to see the greatest problems at higher elevations, and also we expect, of course, some species will become extinct. The threats to water and food, the potential damage to infrastructure, and the impacts on population health and safety mean that we expect to see increasing migration from low-lying islands to higher islands, but also to continental sites. And finally, these changes also threaten indigenous cultures in many ways, including damaging coastal artifacts, threatening traditional food sources and subsistence fisheries, and really eroding the connection, the sustained connection that many cultures have with the land that is a key component of the beliefs and customs that have been developed over generations. So while this is a very sobering set of findings that we're reporting, I think there's great value in this assessment in that it gives us a really comprehensive picture, as we know it right now, of the current state of the knowledge about climate science and the potential impacts on a variety of different sectors. And so we're looking forward very much to using that knowledge and talking with policymakers, natural resource managers, and others about the findings and what the implications are at a very detailed level for preparing for the future, but also managing the conditions that we have right now.
Good morning. I'm going to change directions just a little bit and talk about one of the more specific focus areas that we looked at in the PERCA, which was the freshwater and drought focus area. So, as Melissa was talking about, we gathered a bunch of experts together, kind of the leading group of hydrologists, meteorologists, climatologists in the Pacific Islands region. Sounds like a beginning of a joke. Happens when you get all the leading scientists together in a room for one day to talk about consensus on freshwater and drought trends and projections for the sub-regions, actually, but I'll just be talking about the Central North Pacific today. So these 4 bullet points focus on some of the main consensus points of the group that we came to agree on throughout the discussion in the day. So firstly, because of their small size and isolation, a lot of these Pacific islands have very fragile freshwater resources, making them more vulnerable to climate stresses than continents. This is especially dire on low islands, so low islands and atolls, in terms of vulnerability due to their small size and limited natural and socioeconomic resources. Something else that the group was very interested in was the strong influence of climate phenomena such as the El Nino Southern Oscillation and the Pacific Decadal Oscillation superimposing short-term variation on long-term trends in precipitation, which really makes it difficult as a region to make accurate predictions on a shorter-term level with that added noise in the system. And then finally, there's becoming more and more of a dearth of monitoring and data resources in the region for climate and hydrology. So to accurately assess these trends in water resources and climate, we need more data and basic monitoring, and we need to support those efforts. So one of the first things I wanted to talk about was, you've probably heard this throughout other talks, is air temperature in Hawaii is rising, and it's risen significantly in the past 100 years and accelerated in the past 30 years. And as you can see from the lowest graph on this slide, the high elevation stations are having a steeper rise in air temperature over the past 30 years, and this is work by Tom Gianbaluca. Kind of the way that we did it in the consensus meeting was, oh, I have to push that. Yeah, it's one behind on this one now. I got it now. Sorry about that. So as you can see from the bottom graph, at high elevation stations, that air temperature is rising much more steeply in the past 30 years. And this is Tom Gianbaluca's work. And really, when we had the group in the room, the scientists were talking a lot about which key figures they wanted to present in the report. So which results they could come to consensus on and really agree that this is a key message that they want everybody in the region to look at and kind of look at as a synthesis of climate knowledge, and also for the other subregions. So precipitation patterns are also changing. This is work by P.S. Chu. So in the upper right, we see annual precipitation trends decreasing significantly in the past 30 years. If you look at the last 100 years, there is a slight downward trend, but it's really most distinct in the past 30 years. And then in the bottom, in the past 30 years, all Hawaiian islands have experienced greater numbers of consecutive dry days and fewer days of intense rainfall. So what you're seeing on that graph is each of the 4 main Hawaiian islands, and looking at the larger the triangle, the trend in consecutive dry days. Finally, as Melissa said, the base flow, the groundwater component of stream flow, is decreasing across the Hawaiian Islands. I believe this is 8 out of 9 stream gauges that, with this long continuous record of 100 years throughout the islands, are showing significant decreases in base flow. And then one is showing a non-significant trend that's still downwards, excuse me. And finally, as I said, these monitoring stations are decreasing, not only in Hawaii, but throughout the Pacific. So this entire region has increased, or has shown this decrease in stations and monitoring, peaking in about 1960, and then with the number of stations we're down to now with stream gauges, it's down to almost beginning of the century levels. And of course, this is for a variety of different reasons, but we really need to keep these stations going to meaningfully assess future changes in climate. And the last thing I'm going to talk about is just a case study that So for each of the chapters, we highlighted some case studies of climate in the different sectors. So this is kind of a study of looking at using climate information for decision making, protecting water resources. So this is a case of the PVT landfill here on Oahu, and how they successfully use climate information in decision making. I mean, it's really a unique story. It's a concrete example of a private entity using a climate forecast instead of a weather forecast to really implement flood loss mitigation measures in Hawaii. So it's the first documented and significant example in Hawaii, and I believe one of the first examples in the world of really having these concrete numbers. So basically the story was in October of 2010, the World Forecast Office, or Weather Forecast Office in Honolulu conducted their wet season briefing. According to Center for Climate Prediction, they were showing that sea surface temperatures were demonstrating a moderate to strong La Nina predicted with above winter rainfall. So they gave this forecast, this climate forecast for the season, and a decision maker at the PVT landfill saw the outlook and knew he had to make a decision. He could either take the money that they had for repairs that season and use them to resurface roads on the facility, or they could upgrade stormwater capacity on their site. Because of that La Nina forecast and the fact that they were predicting above average rainfall in the winter, they chose to spend the $300,000 on their stormwater upgrades and left the road unupgraded. So the storm event was on January 13th, and it was a slow-moving cold front that delivered 9 to 11 inches of precipitation in 24 hours in a region of the island that only gets that much usually on an annual basis. So while another landfill on the island was shut down and had a lot of health impacts, PVT remained in operation. They were open the next day for business, able to divert all that stormwater. They avoided losses that they estimated at $600,000 in sales, $100,000 in salaries, from $300,000 to $600,000 in damage to the roads in the landfill. By keeping their construction landfill, the only one on Oahu, so by keeping it open, they saved additional millions by not having to shut down all the waste from all over the island. And there was where the landfill and the storm both were. And that is it for me, and I'll turn it over to John now.
Aloha. I'm going to talk a little bit about the results from the sea level inundation work. So sea level is rising. It rose about a half a foot over the last century. At the current rate, it will rise at about a foot over the next century. But our projections are such that it's probably going to be about twice that. So we're probably looking at a couple feet, maybe 3, maybe even 4. And that's really what the figure is showing, that it's basically you're watching sea level track, particularly on the right where it says in situ data. That's essentially the sea level stations, tide stations. And that's the rate during the previous century. And then it starts to ramp up in the 90s, about the time the satellites come into the picture. And then there's a considerable range of uncertainty, primarily because we don't really know how fast the ice is going to melt. And I think the key thing there is we've kind of tracked some of those down, and it's probably a couple feet, maybe 4 feet, but it's not going to be 10 feet. And it looks like it's even, we're not going to be underwater by 2100. And I think that's fairly significant, just in that, there's been a lot of speculation. The other thing that's important to remember here is that this is a global average. And that's what in the next slide, I want to emphasize this point. So it's not steady, and it's non-uniform and non-steady. And so what you're looking at in the right is the actual distribution of sea level, the rates of sea level rise over the last roughly 20 years. And you'll see that most of the sea level rise contributing to this increase globally sits over in the Western Pacific. A lot of the west coast of the U.S. has actually declined. And that's the primary basis for this is the fact that we have Victoria alluded to it, these decadal periods of variability, the Pacific Decadal Oscillation. Essentially episodes where sea surface temperature and really the trade winds, almost the breathing of the planet, if you like, the trade winds are sort of ramp up over an extended period of time on average, and they literally are blowing and piling water up against the western Pacific. I mean, it happened, that's the way, the base condition is always that way, so it's just a period of increased trade winds and then increased sea level rise. And that's what you're seeing on the bottom then figure there is essentially on the top piece of that is the sea level in the western Pacific tracking up over time, and then on the bottom is the Pacific Decadal Oscillation Index, which you notice is phasing in and out. And so you're seeing sea level phase in and out along with that. So a lot of the previous figure and a lot of the figures we see this nice gentle sort of uniform rise in sea level, and that's not really the way it works. It's really much more of a incremental and uneven. So yeah, it's going up, but it's kind of going down and up and down and up and up and slowly rising. So that's a key point in terms of how we begin to think about the impacts of sea level rise. Again, what I showed you really we're talking about means. And from a decision-making standpoint, the mean water level, the 1 foot in 2050 isn't necessarily what you really need to know or need to worry about. It's typically the extremes. And if you think about it, it's pretty straightforward that if we've got this increasing background over time, this increasing sea level over time, we're going to have more events that hit extreme water levels. Not necessarily that we have more storms or there's actually increased frequency in the sort of synoptic side of it, although there may be. We don't know that for sure. Are there going to be more tropical cyclones or more storms up in the Aleutians? We don't know that, but we can just, even independent of that, just as we track water, as the water level goes up, you're going to have even the regular storm that never really got that high is going to be higher over time, and so you're going to have more what are felt as extreme events. The other thing that's important, and what I'm trying to show in this figure on the right with all the dots that's not particularly clear, is that these extremes are really a combination of the tide and then what's referred to as non-tidal residual. So that's all the other things on top of, or that the tide sits on, or on top of the tide, kind of a combination of both, really. That's things like, the water gets warmer in the winter, so there's a little bit of thermal expansion. You may have the ENSO, El Nino, come in and ramp up the trades and pile up water a little bit higher for a couple months. You may have an extratropical storm or a tropical cyclone come in and generate some storm surge or run up. So those are what all are contributing to this total water level, if you like. And the key point that this figure is beginning to get at is the idea that, not all locations are created equal. This non-tidal residual component varies considerably from location to location. And so in the figure where it's showing residual on the right-hand side and tidal on the left-hand side, it's showing how some stations are dominated predominantly by this tidal signal. Other stations are dominated by the residual. In other words, they're dominated by, the extremes are dominated by storms. And as you begin to bounce around in different locations, you see different combinations. So a good example is Midway versus Guam. The non-tidal residual over time is about the same elevation, if you like, but in Midway, it's a whole bunch of storms coming in over a short time period. Whereas in Guam, it's basically an increase in the main background level over an extended period. So it's felt very differently in terms of impacts. Similarly, you can make distinctions between Hawaii and Guam. Hawaii, there tends to be the high winter water levels in December because that's when the solstitial tide is, and then you get the extratropical storms that drop in, and so we get our extreme water levels along the North Shore, for example, in the winter. Every once in a while, we get a hurricane on top of that. In Guam, it's primarily these low background levels, but then hurricanes come in. And so I'm just trying to illustrate, again, this point that it really, It varies from place to place. And you need to factor in things like ground motion. So even though we have the same basic water level situation, for example, in the Big Island, you've got places like Kapoho that's sinking. So it's going to see each of these locations are going to see sea level rise in a different way. Okay. And it's kind of the idea then that really one size doesn't fit all with respect to impacts. It really depends on the location, and it depends on what's of interest to you. So the 1 foot in 2050 doesn't necessarily mean a whole lot. It's how is that going to be expressed at your location. So there's a couple plots on the bottom that are just examples of some experimental products. And where I'm going with it is that on the bottom, if I'm somebody like the Department of Defense or Army Corps of Engineers, and what's really of interest to me is I need to build a seawall or some infrastructure, and I want to know what's the water level going to be like in 2040 because I need to be able to withstand a 100-year storm event. That's what you're seeing on the left are return level curves for different sea level scenarios. So that gives you some indication of what's the difference in that water level on the left there's 15, 25, 35, 20 or 30 centimeters difference depending on which sea level rise scenario you take, and then what return interval you want to take. So your 100-year storm on the far right, if you look at the 100, that's sort of the range as a function of those sea level scenarios. The figure on the left, we kind of on your right, flip that around, and in this instance, let's take something like a manager in the Northwest Hawaiian Islands who has some threshold elevation that they know that's where basically the beach gets covered or the sea level, the seal haul out area is inundated. And so what you're seeing there is depending on which scenario for a particular elevation, what year does that begin to happen? And so if you track along the bottom, the point where what this is showing is the point where the highest observed storm ever in Honolulu, so the 100-year event becomes the 1-year event, starts to happen every year, depending on which scenario starts to track around somewhere between 2030 and 2050. So, and each location is going to have a different version of these. And so from a decision-making standpoint, it's going to be really important to think about it, much like we say with downscaling. We need to downscale. Everybody recognizes we need to downscale temperature and rainfall. We need to downscale sea level. And then I have, 30 seconds? Okay. The impacts are relatively straightforward. Really, we're talking about impacts to the natural environment. It's basically, all in the form of increased flooding and erosion. So, inundated taro fields, inundated seal haul-out habitat. The built environment, we're talking about increased erosion affecting infrastructure, water inundation inundation of aquifers, even things like tourism as the beaches disappear. And as Melissa mentioned, really it's all low-lying areas and the things that are soft, so it's the atolls that are particularly at risk. Okay. Thank you.
Okay. Thanks, John. I know. Got it. Now we'll turn to a brief overview of the ecosystem impacts detailed in the PERCA. You've heard a lot about some of the climatic drivers, the rainfall and sea level, but these lead to a lot of impacts at the ecosystem level, and that's actually largely a complex and in some ways unknown topic in terms of the impacts, and I'll talk a little bit about that. Climate variability and the need for more data on trends in species and ecosystems really limits our ability to talk about responses of ecosystems to current climate change. Because there is climate change occurring, but some of the noise, the variation that both of the previous speakers have discussed makes it difficult to tease out exactly which factors of change that are being observed in ecosystems are responding to climate as opposed to some of the other stressors that we're all dealing with in conservation. So the PERCA, therefore, for most of the ecosystems, discusses ecosystem responses projected for coming decades. I'll cover impacts to the marine realm, going from the pelagic or open sea environments to coral reefs, mangroves, and seagrasses. Then we'll examine impacts to terrestrial ecosystems, both low islands and high islands, touch on how freshwater ecosystems may respond to changes in precipitation, and finally we'll emphasize the complex role of invasive species in this emerging picture. I know, that's how I turn it on. As you probably know, phytoplankton drive the pelagic ecosystem, shown here in this schematic pyramid. Climate change will affect the base of the ocean food web, the phytoplankton, through changes in wind patterns and therefore ocean currents, increased surface temperature leading to more stratification, affecting nutrient availability for the phytoplankton, essentially the fertilizer for the system, and decreasing ocean pH from absorption of atmospheric CO2. As the atmospheric CO2 increases, that it dissolves in the surface ocean and lowers the pH, essentially acidifying the ocean. That's causing ocean acidification at a rate not seen for tens of millions of years. The pelagic realm is fluid, but can be grouped into 3 biomes in the North Pacific, marked on this graphic by the dotted white lines. In decreasing order of productivity, they're the equatorial biome, the kind of hot colors down at the bottom, and the graph is color primary productivity, essentially the amount of plant productivity in the ocean. They're the equatorial biome, the temperate biome up in the north. You can see a kind of a blob of green there. And the lowest productivity biome surrounds Hawaii. That's the subtropical biome. As the century progresses, large-scale changes in wind regimes, thermal stratification of the ocean, and ocean chemistry will affect phytoplankton distribution and will likely change the distribution of species all along the food chain. The subtropical biome is expected to expand at the expense of the higher productivity temperate and equatorial biomes. These figures are the changes in total area of those biomes. We've already observed an expansion of the subtropical biome, which is consistent with these climate projections. Fish populations and seabird foraging areas are going to have to shift in response to these changes, causing problems for island nations that are dependent on fisheries, especially in the Western Pacific, and seabirds needing to provision chicks on islands. There's a very sensitive period where they have to be able to forage at sea and bring food back for their chicks. And as some of those foraging areas get farther away, that becomes more difficult. The models also project the emergence of a hot equatorial habitat, which is seawater over 31 degrees Celsius down near the equator, which has not existed previously, at least in recent geologic time. It's difficult to predict which pelagic species will not occupy that novel habitat. We know that rates of coral reef formation are declining in some areas, presumably due to ocean acidification, and coral bleaching is becoming more frequent and widespread due to extreme sea surface temperatures. This graphic summarizes the current level of threat to coral reefs in the Pacific. This is the total integrated threat, including local stresses from coastal development, overfishing and destructive fishing practices, and pollution from sediments, nutrients, and chemicals. Note a couple of things here. There's lots of blue reefs, which are low threat, and many show the benefit of being in protected status or lacking a substantial human population, such as the Papahanaumokuakea monument up in the northwestern Hawaiian Islands. Second thing to observe is right now there are no reefs that are dark brown. That is under critical threat. The effects of stresses on reefs are to make it more likely for the reefs to shift from systems dominated by corals and coralline algae to being dominated by fleshy algae. When that happens, there's a corresponding local loss of many species of fish and invertebrates. But given the right conditions and enough time without high stress events, reefs can recover. By 2030, that's 20 years from now, under a moderate emissions scenario, which is actually under the current level of carbon emissions, the added global stresses of high temperature and ocean acidification will have changed that picture. Being remote and protected are no longer adequate because threats are not from local sources. Fewer reefs will be under low threat, and some would now be critically threatened, including some in this study around the main Hawaiian Islands. And this is the projected status in mid-century under this scenario. Only a few reefs in the eastern South Pacific are still under low threat. These results imply that a high level of local protection only buys time for these reef ecosystems and does not provide immunity to significant change or impacts. Avoiding these impacts would require rapid reductions in greenhouse gas emissions. Seagrass and mangrove ecosystems, which serve as foraging areas and nursery habitat for many coastal species. I know that mangroves are considered invasive here in Hawaii, but in the rest of the Pacific, they're native. Various species are very key to coastal processes and populations of fish. Those ecosystems are expected to diminish due to the combined effects of increased air and sea temperature, sea level rise, drought, and increased runoff and sedimentation, depending on location. Mangroves are mainly vulnerable to sea level rise, especially along developed or steep coasts. Models project a 50 to 80% loss in the Pacific Islands by 2100. Seagrasses are mostly vulnerable to increased ocean temperatures and to changes in salinity and nutrients from increased rainfall, such as is projected for the Western Pacific. Models project a 5 to 35% loss by 2100, depending on the climate model. Sea level rise is a critical concern, as we've heard, to low-lying atolls where overwash and inundation will contribute to the loss of terrestrial ecosystems. High storm waves will reshape and move those islands and beaches and increase salinity in groundwater and wetlands. These changes will eventually reduce or eliminate endemic terrestrial species, seabird colonies, and sea turtle nests on many small islands. Of course, similar events will happen on coastal areas of high islands, with beach retreat, coastal erosion, and wetland changes. But in contrast to low islands, high islands extend upward in elevation from the coastline. There's a lot of specifics that are in the PERCA report, but in general, we can say that existing climate zones are projected to shift, generally upslope, and with some eventually disappearing as temperatures rise. Species endemic to those climate zones are at high risk. Because many island species are endemic, the loss of a species from an island ecosystem often means global extinction. As was said, high elevation ecosystems are at especially high risk because of increases in temperature and decreases in rainfall. Patterns of precipitation in the region will have disparate effects on freshwater ecosystems. In the Western Pacific, you can have increased precipitation and events occurring in the watershed and in coastal areas in response to that. In Hawaii, we're looking at a decrease in precipitation, which is likely to cause a gradual decline of native aquatic species as stream flows decline, and coastal wetlands are affected by sea level rise. Many people here deal with invasive species of plants and animals, and currently that's the focus of many conservation actions, and obviously a huge challenge for us all. These species' response to climate change will interact with those of native species to determine the composition of future ecosystems. We can't just focus on natives, we have to look at the whole system here. And invasive species may become more adapted to extreme temperatures or disturbance based on their source locations on continents. Or they may have broader salinity tolerances in terms of marine species than native species. On the other hand, native species can have advantages. For instance, native fish in Hawaii are more resistant to high flood events than invasives. And many continental weeds and invertebrate pests, including vectors for diseases such as avian malaria, may find the changing conditions very conducive to further expansion into native-dominated areas. So as ecosystems across the Pacific respond to these global forces, the human members of the ecosystems will be affected both directly and indirectly. And here to examine that aspect and summarize the PERCA findings is Deanna Spooner.
All right, so the final chapter of the PERCA report, the second to final chapter, it examines the adaptive capacity of the region. And I'm going to spend just a little bit of time talking about those impacts, but for the sake of trying to allow time for Q&A, I'm going to breeze through the findings that have already been covered by our speakers, previous speakers, and then get to the some final recommendations about potential research pathways. So first of all, we all know that within the Pacific, we have very strong cultural diversity and very strong traditional cultures that thrive because of the connectivity to the rich natural environment. And climate change poses a very serious threat to these lifestyles. Drought and saltwater intrusion are primary concerns, particularly in the low-lying islands, where already we're seeing traditional food sources like taro coconut, breadfruit trees being inundated and those crops actually being killed off because of that saltwater intrusion. And there are also projections around changing ocean conditions that pose some very serious threats to local fisheries, where local fishermen might not have the luxury of getting in a big fishing boat like international fishing fleets and going thousands of kilometers to follow the fish as they migrate to newer climate conditions. Inundation also poses various serious threats to places where people live, to places where their ancestors are buried, to cultural sites that are important for maintaining continuity through generations. And the issue that we really haven't discussed much yet in this panel, but is of high concern to everybody within the region, is the displacement of entire populations. And indeed, there is the potential for the displacement of entire nations, low-lying atoll nations, as sea level rise and other climate factors make it impossible for humans to continue to live in certain areas. This is something that really should concern us all because of the incredible impact to those cultures that will be affected, and also the impact to communities that are currently absorbing folks that are climate refugees. So we've already discussed the key findings. I'm really not going to repeat them again. I'm just going to breeze right through them because you've heard them all. And once again, all of this will be published, so you can read this at your leisure quite soon. So this is what I really wanted to get to, is the further research. One of the benefits of doing this process over the last year and bringing in experts, not only scientists but end users from throughout the region, was really the ability to hone in on the information and research needs. And that's where you all come into play. Many of you, I know, are researchers. Many of you utilize information generated by researchers. So that this continuing dialogue that the PERCA has established, if you're not a part of it, we'd really like you to be a part of it and help us to inform the work that is happening now and will be happening over the next few years. So research on historical, current, and future climate trends, as Vicki pointed out earlier, we've lost a lot of monitoring, not just in stream flows and precipitation, but a lot of other long-term monitoring stations, air temperature and otherwise, have been lost throughout the region or have never existed throughout the region. So we need a concerted institutional investment in reestablishing and establishing new monitoring stations. And community involvement and citizen science could be a key to this. We also need more expertise brought to bear on integrated models. Currently, right now, there are very few modelers who can really pull together the climate model, the biological, the geochemical, the physical models, and start synthesizing them and giving us a good picture of the localized, the regional, the sub-regional, and the localized trends. And as has been touched upon already, we really need a deeper understanding of human responses to climate change. Not only how individual communities respond, but how institutions respond, how governments respond, and how policy structures can shift to help us all within the region adapt to the onslaught that we know is coming. Before we go into the Q&A session, I did want to put up, this is just a partial list of all the folks that have been involved over the last year. Many more have participated in the technical workshops and the peer review of the PERCA report. And lastly, if you want to contact any of the leads on this effort, here's our information. I'm going to leave this up during the Q&A. And at this point, I would like to ask for a round of applause for all of our panelists. And then we've opened it up now to Q&A from all of you people, and I know some of you are actually doing this work, so if If you have any questions or you want to raise a topic for discussion in the next 10 minutes, now is your chance. Okay, to summarize the question for those who couldn't hear, as we go into this new normal, as ecosystems shift, how are we going to be, how do we distinguish between invasive species and just natural shifts in species, populations, and compositions?
I guess that goes to me. Well, this is obviously a big topic in terms of policy because a lot of area managers that are charged with protecting the integrity of areas or running programs to keep areas free of invasive species have a clear interest in what to target because you can't target everything. I think this is a different question in marine processes than in terrestrial. Our islands are so isolated that terrestrial species getting here is an extremely rare event before humans arrived. So I think in the terrestrial systems we have to really be concerned about what's here already and how those species are going to respond. It's different in the marine realm because of the fluidity and the fact that those species are usually wide-ranging. So if bowhead whales come here and fur seals come here, I think they just want a vacation, but it's going to be difficult to really, obviously you can't prevent movement of species, and so you have to, it's a policy question, and I think the policy has to reflect reality, and there's probably a lot more leeway than we think in terms of figuring out what to target because we can't target everything right now. So it's, the term that's been coined on the mainland for this is neo-natives, that these are native species that we just have to welcome because they need a place to live and they're shifting their ranges. I think this is really an open question in terms of Hawaii because it's so isolated that we're going to be, I think, one of the last places to see this phenomenon occur at a large scale. I've just thrown that out there.
Other questions? If you could please approach the microphone so everybody could hear your question, that would be fabulous. Thank you.
Hi. I'm curious if you have any thoughts on bridging the gap between the scientific community and groups like yourselves and local government and policy actions, kind of, how it's being implemented or that starting, or if it's not, starting to happen at the local level with policy and decisions.
Sure. Excuse me. Very important thing to do and currently underway already, but much more to do. So in terms of the PERCA itself, we have, this is a sustained process. So we've begun identifying key information that we have available to us, and we have a number of dissemination and dialogue activities planned as that information becomes available. As Deanna said, there were many groups involved, or we had over 100 people involved in this process, so we have a pretty good starting point for how we can reach out and identify others that would really value this information. The question of how to actually translate it into something that policymakers and decision makers can use, explore more in depth and implement in terms of the short-term and the long-term decisions they're making, is actually a topic that the Pacific RISA program is designed to address. So this is called a RISA for Regional Integrated Sciences and Assessments, and we have both physical scientists and social scientists involved. And our job is really to be like an experimental test bed. So once we have new information like this, how do we translate it? But also going the other way, how do we identify what communities need? And our particular focus so far has been on freshwater resources and looking at water managers and other communities that need information about what's happening to freshwater resources. In their day-to-day activities, what kinds of decisions are they making that are climate sensitive, whether they realize it or not? And how do we infiltrate that decision process at what point with what kind of information? So it is a research program, but it's also an iterative two-way dialogue that is ongoing and takes some time. But maybe John might want to also, do you want to address anything through Paxis or Regional Climate Services?
The only comment I would make is, we talk about this as a sustained assessment process, and so this was really the first step, was basically assessing the state of knowledge. And I don't know if it was in the picture that Melissa put up, but the next round is essentially a series of dialogues with policymakers, decision makers, to have this sustained dialogue and address those sort of questions. So we're thinking about, I think it's December, January, February, essentially having 3 large workshops, forums, whatever you want to call them. One here in Hawaii, one in probably in Fiji, and another one in Guam, to get specifically at that. Okay, here's what we know now. What are we going to do with it?
All right, we have time for one quick question, and then we'll have to wrap up.
This is horrible. I was actually wondering if you could go into a little bit more detail on, so you said that there were 100 groups involved, and I'm wondering about sort of non-traditional scientific communities and how those were involved in the research, and what kind of dialogue you've been having with them in terms of integrating all of the knowledge about what is already going on into the assessment.
So in this first round of the assessment, I would say that we've begun to reach out to traditional ecological practitioners and traditional communities, but we've not gone as deeply and made as much engagement as we would like to. And for the most part, the people that we were able to engage with, it was under the auspices of the National Climate Assessment, who funded a workshop here in Hawaii around a chapter that's going to be in the National Climate Assessment on tribal and indigenous knowledge and climate change. So that workshop was sort of the starting point. Through our assessment, we also had some folks, mostly from Hawaii, mostly from the Native Hawaiian community, that were leading some smaller efforts in establishing dialogues. But if you have any suggestions about broadening that, or you want to get involved, then please come up and talk to us. That would be much appreciated. And that's all the time we have for now. I would, oh yes. Do you, if I ask my question? We need to transition to our next panel.
Okay.
If you could ask it in 10 seconds and it could be answered in 30, then yes.
Perfect. This is actually just about the big picture of climate change. I guess assuming that the sea level will rise like the research shows, is there anything being done right now, policy, money being set aside for, the first environmental refugees, like in Tuvalu, they're already suffering from sea level rise. They may very well be our first environmental refugees. So is there anything being done? Money, policy?
Yes, at various levels, and the individual to talk to about that here in Hawaii is Maxine Burkett at the law school at the University of Hawaii at Manoa. She's one of the foremost experts on that issue. In a nutshell, most of what's being done is happening through regional and sub-regional agreements between nations. The larger global negotiations aren't making much headway, and so what we're finding is that individual nations like Fiji, New Zealand, Australia, and others are stepping forward in the region and negotiating with governments from low-lying atolls and figuring out methods for helping to assist the translocation of populations. So I'm sorry.
Thank you.
Yeah. Okay. Thanks. So we do need to transition to our next panel. For those of you that are going to remain on, just give us a minute to make that transition. And for those of you that are going on to other sessions, thank you for joining us.
Saw the email.
Do you have a minute or?
All right, so I'm going to start on introductions while we get presentations up and we wait for our second panelist. So this session obviously is a climate change themed session, and the first forum was really looking at the what's at the state of our knowledge in the region, in the Pacific Islands region. This next forum is going to be honing in on some climate adaptation tools, and basically we're going to be talking about how do we take that knowledge, both knowledge derived from Western scientific inquiry and from traditional inquiry, how do we take that knowledge and start to synthesize it into tools that can inform adaptation efforts? It's a big topic, and rather than try to paint that big topic with a broad brush, what we're going to do is we're going to talk about two tools in particular, and through those two, the examples of these tools give you an idea of the variety of approaches that can be taken by governments and local communities to incorporate climate change projections and information into adaptation processes or just general resource management planning processes. Let me make sure that we've got our PowerPoint. Nope. Okay. This is it. All right. So before we get into, before I introduce the panelists, I just wanted to very, very briefly talk about how this panel came about. And it was a conversation between the Pacific Islands Climate Change Cooperative, or the PICSI, and the Micronesia Conservation Trust, or the MCT. We've been having a conversation for almost a year now, since the last HCC, about working together to help disseminate tools around climate adaptation. And through a series of conversations, we decided it would be really useful to actually bring a couple of tools to this year's conference. So through those conversations, we decided we would focus on two tools. The first one is called the Vulnerability Assessment, which, as the name implies, it examines the potential impacts of climate change on natural and cultural resources and their vulnerability to climate change. And then the second tool is something that has been developed in Micronesia. It's the Micronesia Climate Change Adaptation Toolkit, and then it's been developed by the MCT and many, many other partners, and it's being employed in communities throughout Micronesia to address key challenges faced by communities that are actively carrying out adaptation activities. So once the presenters present on these two tools, then we are going to have a really fun interactive Q&A session where we're going to be able to bring up folks from Micronesia who have actually been using the toolkit and in various communities to share their knowledge and stories about that. One last thing I'd like to raise is this concept of climate change adaptation. For those of you that don't work on climate change or adaptation, it may be a phrase that you're unfamiliar with. There are a lot of definitions out there, but I did want to put forward the one that was developed by the Intergovernmental Panel on Climate Change, or the IPCC, which is sort of the world's foremost gathering of climate scientists. And the way that they define adaptation, I think, will help us in this session. Adaptation to climate change takes place through adjustments to reduce vulnerability or enhance resilience in response to observed or expected changes in climate and associated extreme weather events. Adaptation occurs in physical, ecological, and human systems. It involves changes in social and environmental processes, perceptions of climate risk, practices and functions to reduce potential damages, or to realize new opportunities. Adaptations include anticipatory and reactive actions, private and public initiatives, and can relate to projected changes in temperature and current climate variations and extremes that may be altered with climate change, such as storm events. In practice, adaptations tend to be ongoing processes reflecting many factors or stressors, not just climate stressors, rather than discrete measures to address climate change specifically. So that's the basic framework under which we're going to move forward with our presentations. I'm going to introduce our first speaker, Dr. Lucas Fortini, who is a research ecologist with the PIXI under the sponsorship of the U.S. Geological Survey's Pacific Islands Ecological Research Center. Lucas has a PhD in tropical forest ecology and management from the University of Florida and a bachelor's in science and resource management from the University of California at Berkeley. His research interests include applied ecology, species and community responses to climate change, defining optimal management regimes within multiple threat contexts, developing science-based tools for climate change adaptation, tropical forest ecology and management, and population and community ecology and modeling. And Lucas is also a very accomplished musician. So join me in welcoming Lucas and his presentation on vulnerability assessment.
Okay. Great. Okay, so good morning. I'm here to talk about this large collaborative effort that I'm leading among several colleagues from conservation-oriented organizations here in the state of Hawaii. This is a very large effort, in essence, a climate change vulnerability assessment for all main Hawaiian Island native plants and forest bird species. So it encompasses over 1,000 species, over 300 of which are threatened and endangered. And it's certainly something that would not be possible without the collaboration from all of the partners that I have listed and colleagues that I have listed in the slide, and many other people that have contributed significantly to the effort so far. So it's very important to mention that this is an ongoing process. We are still right in the middle of it with a lot of things going on at the same time. So today I'm just going to give, in essence, a short overview of the effort and how and why we did things in a particular way to fit our assessment to a Pacific Island context, and then a second part of the talk focusing on some of the lessons that we have learned along the way that hopefully will be useful to others interested in climate change adaptation in Pacific Islands in general. So up to now, climate science has focused largely around the issue of climate uncertainty, but for ecologists, it's increasingly clear that the ecological responses of species and communities to such climatic changes are much more complex and uncertain than the uncertainties in climate itself. So as PIXI is charged with providing information to move climate change adaptation forward in the Pacific, we, after discussion with our broad membership, we decided that one way to move this climate change adaptation forward in the Pacific is to start elucidating some of the potential ecological impacts of climate change to our native biota. And vulnerability assessments are just one of the ways to do that. And you can think of them simply as an effort to summarize all relevant knowledge that is available to understand potential impacts of climate change to a resource of interest. In our case, of course, our native species of Hawaii. So as we started this process in about fall of last year, we quickly realized that we had some substantial challenges that we had to overcome here in the Pacific region, and some of them including the fact that we do work at a very data poor region, and that in general, there's very little information available, and also there's very few types of information that are consistently available across all of our species of interest. Additionally, unlike what's commonly done elsewhere, we quickly realized that we couldn't look at climate change in a vacuum because, as mentioned in prior talks, there are already some substantial existential threats to a lot of our biota here in the islands, and we couldn't just think of climate change without such an important context. Lastly, we have a huge amount of species that are of conservation concern and of cultural significance here in the islands. And we knew that we couldn't come up with a method that worked perfectly, but only for a few small set of species. We had to come up with something that could be easily reproducible and flexible to reflect the differential amount of data available for a lot of the species that are of interest to us. So there are existing tools out there to determine what is the relative vulnerability of species to climate change. And these are what I call spreadsheet models. And these essentially rely on experts exclusively to rank the vulnerability of species to climate change by considering a set of general factors that are generally related to climate change vulnerability. For instance, dispersal capacity, dietary versatility, and so forth. The issue with these approaches, though, is that there are a few limitations that really hinder their applicability to our settings here. First, the fact that they rely heavily on experts. They are conceptually and simple and easy to apply, but they're very burdensome for you to apply over several species. Each species require a set of experts to sit through this exercise and rank these species. And also, as using an expert as a black box source of information, it becomes very hard for you to update these assessments with a rapidly growing knowledge about climate change impacts. Also, because these standard approaches look at vulnerability or define vulnerability in this general set of factors, they essentially decouple the assessment for potentially very useful quantitative research and model-derived information that you can get, for instance, from species distribution models and so forth. And again, as a lot of these tools have been created in other contexts, they do not do a particularly good job at integrating climate change within a context of other threats as well. So with that in mind, we ended up kind of drafting our own approach to dealing with vulnerability for our species here in Hawaii, utilizing primarily a Bayesian network model approach. And I know that usually Bayesian network models are Bayesian models usually entail some level of complexity that's somewhat intimidating, but I want to argue that in this case, this type of modeling is actually very simple and very intuitive. And it's a type of approach that's increasingly being used in ecology and conservation biology that is essentially just a very intuitive way for you to define the knowledge base about a particular issue of topic of interest. And this type of approach is particularly useful for applying to areas where there's a lot of uncertainty, and of course, that being the case of climate change science in the Pacific. And you can think about these Bayesian network models as being composed of two simple components. One is a graphical representation of the causal links among the factors that define the system or the issue that you're trying to understand, and then the underlying statistical inference engine that over 95% of the users do not have to concern themselves with. So it's not as complicated as it seems. So looking just as an example at a subset of our preliminary model of species climate change vulnerability, we can think, for instance, of the likelihood of a species moving its distribution within an island in pace with a shifting climate as being partially defined by a suite of general causal factors. And with any of such factors, then being defined by a whole set of other sub-factors. So it's not like creating this complex network model assumes that we expect to have the information available for all of these factors for any given species. But what's powerful about this is that we can start populating such a model for all of our species with the data we have, and we can clearly see what are the gaps and how important they are. They may influence the results we're getting based on the limited information we have. So we hope that by utilizing this type of approach, we can circumvent a lot of the challenges and limitations I had outlined before, namely by using this type of framework to provide a pretty comprehensive representation of how species may be responding to climate change here in the islands, and while doing so, providing a means to address that interaction with non-climatic threats along the way. And the other positive aspect of utilizing this approach is that Bayesian network models are known to be very flexible in the types of data sets that we can include in such models. And in essence, we can really maximize the utility of the fragmented type of data that we have for all of our species out here. And this is also related to the issue of the unavoidable data gaps we encounter along the way. And the Bayesian network framework provides a very rigorous way for us to define what are the gaps that are most important and that should be the target of future research along the way. But perhaps most important, and perhaps the biggest selling point about this type of approach, is that this type of framework allows this process to be a dynamic process where we can continuously update these models with improved information about our species responses and its biology. So we come up with a process that improves over time. So as mentioned, this is still an ongoing process effort. We expect to get our first products out in about 2 months. But yet along the way, we have gathered some lessons that we hope that is going to not only be relevant to ourselves as we look forward other vulnerability assessments to conduct in the future, but possibly to other people that are interested in climate change adaptation out here in the Pacific. So I'll just go over some of the lessons we learned along the way. This is by far an exhaustive list, but time is of essence. So first, in the vulnerability assessment literature, there's a frequent mention of considering end users' needs and interests throughout the process as best as possible. But what we're finding along the way is that actually there's, in some cases, there's a scientific capacity of our intended end users is limited, and you might actually gain quite a lot from going beyond considering the such general needs and start thinking about how, where, and when this information might be taken and considered by the end users that you intend the vulnerability assessment for. Another thing that's often overlooked in conducting of such vulnerability assessments is the fact that if you want to have researchers be a substantial contributor to these efforts and scientists, you need to keep them interested. And that means that you have to come up with a process that is very scientifically rigorous and that includes some level of intellectual stimulation so you can get them engaged over time. Of course, as mentioned before, there's a huge amount of uncertainty in terms of climate change science out here in the Pacific. But for vulnerability assessments out here, I really suggest that we have to address that head on. And that means first talking about and discussing these likely uncertainties and their potential consequences to the likely products that you may get from such an assessment, even before you decide on a particular topic or scope of an assessment with your end users. And of course, there's many ways that you can deal with uncertainty during the analysis itself, standard sensitivity analyses, permutation procedures, and so forth. And in our case, for instance, using such a framework that it really builds uncertainty deals with uncertainty at its core. And lastly, what you can do in terms of addressing head-on is once you finally have your results out there, you just have to be really careful to caveat your results in a way that end users understand what are their limitations and what are the potential misuses of the information you're providing. But perhaps best way for you to deal with uncertainty over the long term is think about these vulnerability assessments not as a single one-time shot product and more of a dynamic process that hopefully you can keep alive and update over time with a relative ease. And that's why we have mainly chose this Bayesian network model approach. A few other points that I think are very worth mentioning is the fact that vulnerability assessment is by far not the endpoint of the climate change adaptation process. That path in itself is not very clear. There's a lot of people thinking about how to bridge between these vulnerability assessments and climate change adaptation. But one thing is for certain, and this is something I learned from talking with dozens of researchers that have conducted vulnerability assessments elsewhere around the globe, is the fact that the assessments that tend to be most used by the intended end users are the ones that have, from the beginning, have considered some follow-through actions along the way. Having said that, there may be some situations where vulnerability assessments may not be the best first step in a climate change adaptation planning. And you may be best suited depending on what's the state of your community in terms of climate change knowledge with other exercises such as scenario planning, other strategic exercises, and so forth. But I would just like to finalize this quick talk with rebuting a common excuse for not conducting vulnerability assessment or adaptation planning in general. And that is often repeated excuse that managers and conservation practitioners already have too much stuff in their plates, and they possibly cannot consider climate change as an additional factor in their decision making. And it's true that in some cases ignoring climate change for a while may be fine for now, but the fact is that the longer we wait, it's more likely that we're just getting into more costly interventions in the future, or possibly being just too late for us to do anything about it. And it's not like by going through a vulnerability assessment and the following adaptation planning that you will end up with recommendations for managers that require them or suggest that they drop all of their current priorities, conservation priorities. And in fact, most climate change adaptation recommendations tend to go hand in hand with good general conservation practices. If that's not the case, maybe something wrong went wrong along the way of the process. And the stark reality here for the region is that everybody knows we do not have all the resources to fight and win every single battle in conservation here in the islands. And just really being refining the ways that we prioritize our battles and our interests is really a smart way for us to allocate resources over time. So anyway, I have glanced over a lot of the technical details of the assessment. So if you're at all interested about that particular facet of this work, please talk to any of the people involved in this assessment as I listed in the first slide, or talk to me at any time, or email me. So thanks a lot. Yeah, we have time for one question. Yeah. So the question is about how we are trying to communicate directly with the public in this type of work. And I think that as a scientist fully engaging now with climate change adaptation work, I also feel the same way. We have to, I know that professionally we tend to be judged by our research papers, but I think that it's really at this time, unfortunately, I think that for most of us, it's an additional weight to our responsibilities, but I think if we're serious about really making a difference, is a responsibility that we have to take. Pixie as an organization, in itself, we have hired specifically a climate change communication manager to help us be able to have that broader messaging besides just the hardcore technical outputs that we get out of such efforts and other related efforts. So we do recognize that that's very important, and we're learning through the process as well. Diana, you might have something to say about that.
I would have a lot to say about that, except I'm cognizant of the time and I want to give enough time to our speaker. Although I think your question is actually a natural segue into our next speaker, because what we're going to be learning about is exactly what you're talking about, how you engage communities, how you engage citizens around making decisions with the best available information. So I think if that's okay, we'll leave other questions until the end, and we can come back to this question about, bridging the gap between science and action. So I'm so excited to introduce our next speaker. Although she was recruited at the last minute to give this presentation, she's just been very, very wonderful to get to know over email and in person here at the conference. Berna Goring is the in-country regional mentor with the Pacific Islands Managed and Protected Areas Community, or PIMPAC. And this is a network in Micronesia. And in this role, amongst many others, because she wears many hats, Berna serves as the climate educator, training agencies and community facilitators in utilizing the Micronesia Climate Change Adaptation Toolkit as a tool in engaging local communities in their planning processes. And as I mentioned earlier, this session was originally organized in conjunction with the Micronesia Conservation Trust, and they've asked Berna to do this presentation on their behalf.
Well, I'm community-based, so this tool that I'm going to talk about is sort of my reaction of being in the room with a lot of the science and all the technical information being thrown around. That was the challenge in our region in trying to share the information on climate change with our communities. The toolkit was developed with its collaborative effort. Some of the logos that we have on screen right now, Micronesia Conservation Trust, and there are several other partners of, I don't know what you call them, technical partners or donors or supporters that were also very key in helping get the toolkit out, like the NOAA program and the German LifeWeb grant. Okay. And we also have the logo on there of the Micronesia Challenge, which is a regional initiative by 5 jurisdictions in Micronesia to effectively conserve terrestrial and nearshore marine. And because of that work on the ground related to the Micronesia Challenge, communities were engaged in helping them in the planning process, assisting them in their planning process. And climate change, as they're identifying threats to their resources, climate change was coming up as a threat. And one of the, not one, but many of the challenge with the agencies and support partners that were supporting the communities is that as there's a lot of information on climate change and adaptation, and all these are at regional, international levels. And you can't take, all this information like the ones that are being shared here and share it directly with communities. And in our region, the resources and the people that manage it and use it are really communities. So that was one of the major challenges. How do we share this information with our communities in a way that's meaningful to them? And there were also not enough information gathered, in our region that can be shared with community that's more relevant with them. And there weren't not too many adaptation models, community-based. So MCT and the PIMPACT network, I took the lead in starting this project. And the first part of it was reviewing all the existing materials that was available internationally and also in the region. And also, since we already have management planning models and tools that communities were already engaged and using, they wanted to incorporate, like a climate lens into that management planning process instead of coming up with a new assessment entirely on its own and not linked with what's already being used by communities in their planning process. And the other approach was that climate change, it's one of the threats, major threats in the region, but it's not the only threats. And communities are also looking at other threats. So in September 2010, there was a climate camp workshop that was held in Pohnpei in the FSM. And it brought together community members from communities, resource managers working in the region, and also climate experts. And from my experience in being involved in the conservation work, this was the first workshop in the region that had community representatives, had community members as part of this group that came together and discussed how do we share the information on climate change that's available with the local communities. And during that meeting, it was one of the key points that was made by the community reps there was that we needed to have outreach material that was condensed or, with all the information on climate change, brought down to a level that you can share it with the community leaders, the traditional leaders, and they'll be able to understand it. And the materials or the communication needs to be culturally appropriate. It needs to work within the traditional communication or context of the islands. So that workshop in 2010, in 2011, it was completed. The toolkit was completed based on the recommendations that came out of that workshop. And there was 5 products. The first one was one of the management planning guide that was being used in the region was the PIMPACT management guide. So this was revised to include a climate change lens in there, which has vulnerability assessment that can be done by the communities themselves as they're facilitated through the process. The second item of the toolkit, and this is the highlight of the toolkit is large flip charts, and this was the outreach. And I didn't bring a copy with me because it's oversized and quite costly to transport from Micronesia to Hawaii. But we'll be sharing pages of it for you to see. And the other part of the toolkit was a facilitator's guide, which was to help the community facilitators. And then there was also a mini booklet of the flip charts done, which also had additional information on that the facilitators could use, and this was designed to be passed out, during the community meetings and community facilitation, so the communities could also have the information that was being presented to them. And then there was also a 30-minute video that was made from people and experts that are working in the region that could also be shared with the communities or with the communication outlet stations in the region. So the flip chart, that's really the highlight of the toolkit, we like to say, because that's what we would use when we get into the community. And basically the flip chart is to really visually convey the basic climate concept to the community in a way that they can understand and tie it, to their traditional knowledge of the weather and the environment as they know it from history. And the other purpose for the flip chart was during the climate camp, a discussion is to mobilize communities, you really need their traditional leaders. And we felt that it was really important to make this toolkit that it's simple enough that even the traditional leader can use it after being trained in it, that they can be comfortable to use this and share the climate information with their own community members and engage them in the management and planning activities. So next, these are going to be the actual flip charts, some pages, because it's actually 20 pages, and they're broken up into different categories. And the outreach toolkit, it starts out not just talking about climate change. So it starts out with looking at what a healthy community looks like and what a threatened community might look like. So that's one of the first flip charts in the toolkit. And this could be used to talk about the natural resource on the islands. And I'm not going to talk specific about, I'll have other members come up and share more. But just to show you what the flip charts look like. And because we have high island and low-lying atolls, the flip chart had images of both showing scenarios of high islands and low island atolls. So this would be like a low-lying, healthy atoll. And a threatened. And this would be used in the community meetings to explain or engage the community members in discussing non-climate threats with the community. The following are the actual climate change pages in the flip chart. And this is the chart on when they can use to talk about what the climate change is. And the 5 predictions for the region. The other set of pages talks about why communities should care about climate change. And then this is used to talk about the different impacts or potential impacts, or in what is already being seen in the region, and how communities can get affected. It goes back and uses the same images that was used when the communities engaged discussing non-climate threats, and then you have the imposition of the climate predictions in it, and what are the potential impacts and cumulative impacts. And this flip chart is also just for an example that they can show projects or activities in other islands of communities taking action. So after the toolkit was developed last year, MCT rolled out, training of trainers or agencies and community members in utilizing this toolkit. And the flip chart is just one part of the toolkit, so this is used for the awareness, and then it's built into the management planning process. And if communities if climate change is something that the community identifies as part of their threat, then there is the vulnerability assessment that's also put into the impact management planning guide that they can utilize. And we just have one lesson learned, and it's really on communication. One of the things about the toolkit is that it really has to be, the local trainers have to, or the local facilitators, agency people, have to understand this. That's why it was brought into like the simple concept, the simplest way, so that they can understand it and be able to translate or convey those in their own language, in the way that the people understand climate and weather, for it to be effective. And I have two persons in the audience with us that they're actually some of the people that are using this with our communities. The training was rolled out beginning last year, and we're done trainings in all the islands. So many of the islands are already using this toolkit and incorporating it in communities that already have started management planning process, or they're engaging them and educating them on the climate outreach toolkit. And those are the people. If you need to, don't call me. Megan Gambos, Scott, and Supin were the ones that worked, in developing the toolkit. And Liz Turk is with the Micronesia Conservation Trust, and you could request more information from her regarding the toolkit. We had a short video. Maybe before the other come up to share some lessons learned, we had this short, like 3-minute video, because one of the things that was mentioned in this is about migration. And even though, we have issues, I think the poem, we thought the poem would expresses really well the point that yes, you could migrate if you're going down under, but a lot of the local people cannot leave because they're linked to their island. So maybe we can get that. Yes. Could you? Maybe you could come. if I could ask, Alban Nishoda is with the Executive Director with the Marshall Islands Conservation Society, and Delegate Wayne Andrew from Palau to please come up and also share some of after the video.
I prepared the package for my friends in the States. The dangling earrings woven into half moons, black pearls glinting like an eye in a storm of tight spirals. The baskets, sturdy, also woven. Brown cowrie shell shiny, intricate mandalas shaped by calloused fingers. Inside the basket, I write a message. Wear these earrings to parties, to classes and meetings, to the corner store, the grocery store, and while riding the bus. Store jewelry, incense, copper coins, and curling letters like this one in this basket. And when others ask you where you got this, you tell them they're from the Marshall Islands. Show them where it is on a map. Tell them we are a proud people toasted dark brown as the carved ribs of a tree stump. Tell them we are descendants of the finest navigators in the world. Tell them our islands were dropped from a basket carried by a giant. Tell them we are the hollow hulls of canoes as fast as the wind slicing through the Pacific Sea. We are wood shavings and drying pandanus leaves and siquipiros at kemems. Tell them we are the sweet harmonies of mothers, aunties, sisters, songs late into night. Tell them we are whispered prayers, the breath of God, a crown of fuchsia flowers encircling Auntie Mary's white seafoam hair. Tell them we are styrofoam cups of Kool-Aid red, waiting patiently for the Ilomid. We are papaya golden sunsets bleeding into a glittering open sea. We are skies uncluttered, majestic and sweeping in their landscape. We are the ocean, terrifying and regal in its power. Tell them we are dusty rubber slippers swiped from concrete doorsteps. We are the ripped seams and the broken door handles of taxis. We are sweaty hands shaking another sweaty hand in heat. Tell them we are days and nights hotter than anything you can imagine. Tell them we are little girls with braids, cartwheeling beneath the rain. We are shards of broken beer bottles burrowed beneath fine, white sand. We are children, flinging like rubber bands across a road clogged with chugging cars. Tell them we only have one road. And after all this, tell them about the water, how we have seen it rising, flooding across our cemeteries, gushing over our seawalls, and crashing against our homes. Tell them what it's like to see the entire ocean level with the land. Tell them we are afraid. Tell them we don't know of the politics or the science, but we see what is in our own backyard. Tell them some of us are old fishermen who believe that God made us a promise. Tell them some of us are a little bit more skeptical of God. But most importantly, tell them we don't want to leave. We've never wanted to leave. And that we are nothing without our islands.
Wow, that's powerful. I think at this point it would be great for the audience to take advantage of these wonderful, wonderful resources that we have here at the table. Our presenters and the guests who have joined them, who are working on these issues on a daily basis. If you have any questions, please come up to the microphone. If you don't have any questions, then I'm going to start peppering them with questions. So you might want to spare them by asking your own. Okay, I will start. I really want to hear. I want to hear about some stories about using this toolkit and the reactions that you're getting from everybody, from leaders, from school children, from teachers, from people that are engaging in these workshops.
Good morning. My name is Wayne Andrew, and I'm from Palau. We had this training rolled out in Palau January of this year. And we wanted to just also share our story because it's really amazing how, when we first started management planning of resources in Palau about 5 years ago, climate change has always been on the priority list of communities. But we were looking at, overfishing and other issues that, of course, they were important, but climate change has always been put aside and has never been really addressed. And so the reason why we put together this toolkit is as a result of the demand from the community. And when we first had the training in Palau, I was really inspired by the community members who were at the training because they themselves decided that this is a priority and it's not a one person's job. So therefore, at the end of the workshop, we created an alliance of communities that are now working together, learning from each other, and working to help, advance some of the solutions that have been, discussed and prioritized by themselves as sort of ways to adapt to the impacts of climate change. So I think that, the tools that we've developed have really helped the communities, but there is a strong, urgent need within the communities about the need to adapt to the impacts of climate change. As you can see in the poem, we're here to tell you that it's real, it is happening, and the communities are feeling they don't know what to do. And so the reason why the toolkit was created was really to give them an opportunity to really, sit down and look at, what impacts are really human-made and what impacts are climate-induced. And therefore, by looking at those, two different, impacts, they can better, plan for what are some of the things that they themselves can do. For example, if they're looking at, clearing their mangroves, then this toolkit it's a no-brainer. It will tell them that if you clear your mangroves, climate change is going to be more severe and you're going to get it the most if you don't have that mangrove in front of your village. So that's just something that I wanted to share. Maybe Albon can share a little bit about the Marshall Islands.
Thank you, Wayne. I think as Berna also pointed out, and some of the audience also pointed out, the communications is a big issue in trying to deliver these information down to the community level. I think in our experience, again, we were all part of the Micronesia Challenge, and it was focusing on conservation of resources, natural resources, and eventually, it became an adaptation strategy to climate change impacts. So when we were talking about bringing these down to the community, and I'll just give you a quick example of how we constantly struggle with trying to just translate, say the word vulnerability. How do you translate vulnerability to a community in the context that science is presenting? So we were using, different scenarios and factors to measure the vulnerability. For instance, like the sensitivity or exposure and adaptive capacity. So these three things we were actually trying to translate back to the communities. But then we realized, wait a minute, our traditional knowledge already had these things in place. For example, you wouldn't normally, in a local setting, you wouldn't normally build your house at the windward side of the island. And this is a knowledge that goes way back. They were always, the settlements and the communities were always developed on the leeward side of the island. So because our adaptive capacity back then knew what would happen if you would just clear the forest, the windward forest, which we also have a local name for, and build houses there, you will constantly be affected by the changing, whether it's a sea level rise or a saltwater intrusion into your gardens or your taro pitch. So when we took that concept and related to the communities, they were like, oh, yes, of course, we know. And we're like, well, there it is. You know, you already know. This was already part of, you know, you just need to just look around and see what's happening. So when they knew this, it sort of built some pride into their being, this knowledge that's always been available within their communities. And they became more, you know, more aware, and they started coming out and say, what about this? What about that? And we're like, yeah, you see, you're picking it up. So when we worked on strategies, they already had in mind what they wanted to do. So, for example, one of them was like, all right, we're not gonna cut down the windward forest, shoreline vegetation at the windward side of the islands, because they will provide protection and salt. They will reduce the salt spray into our agricultural land, or little agricultural land. In fact, we're going to replant these areas to help build our resilience. So that was just a simple activity that mobilized the community based on just simply communicating what these means to them in their own local context.
Great, thank you. At this time, do any of the audience members have questions?
Thank you. That's a very interesting question. I think the question, if I understood it correctly, is how do you bridge the gap between, or how do you bring everyone together to work collaboratively? Fortunately, in our case, the traditional system is still intact in most of the outer islands. So, you know, we understand a certain level of protocol, traditional protocol, and this is unwritten. And, you know, believe me, we find this challenging at times too. Because these are unwritten protocols. You know, you just had to grow up in the islands to know when to say something or how to say it, or, you know, just, you know, simple things that may make or break, you know, whatever you're bringing it down. I guess one of the things that really helped us in trying to bring everyone together was, you know, making the issue, talking about issues that are valuable, that mean something to the communities. If I'm going to talk about adaptation by, say, protecting the coral, what does the coral mean to that specific community? Perhaps nothing. They don't eat from it. They don't. What we do is we talk about the fish that actually means something to the community. So it's taking something that's valuable to the community. So when we talk about the fish, and my target was the coral, but I talk about the fish and the need for it to sustain them, therefore addressing the habitat, and then they get it. They're like, oh, okay, so what you're telling me is that, you know, by protecting this area of biodiverse, rich biodiversity, then it will sustain the fish. And it's like, yeah, it's as simple as that. Okay, so they take it on. And my point is that it's got to mean something to them. And it's gotta be something that's valued. Oftentimes we bring it down and we say, we got to do this because it's a need. And, you know, whether it's a plant, whether it's a coral, or whether it's an endangered, but if it doesn't mean anything to them, it's going to be difficult to bring them together to agree on something. I hope that answers the question.
If I may add a little bit to that, I think in our case in Palau, one of the things that we're also really fortunate that we've been able to work with the local schools, the Ministry of Education. In fact, there's the PREL program that's also extended out to Palau. And we're working with our school children because we believe that, you know, if we start working there, it will take time, but it's going to make the work 10 years from now so much easier to work with them. Also, in addition to that, we've also been engaging a lot of the media, get them, you know, get a lot of the messages out and getting the right messages out to them, and also looking at our leadership to make sure we have people who can help us champion these issues at all levels, and that's how we can bridge the gaps.
Unfortunately, we've run out of time. If you could all join me in once again thanking our panelists. And for those of you who didn't get to ask your questions, please feel free to come up and speak with the panelists up here. Thank you.